Answer what is asked. Number 1. Find the sum of the first 13 terms of the sequence -3, -1, 1, and 3. Number 2. Find the sum of the first 15 terms of the arithmetic sequence 10, 15, 20, and 25. Number 3. Find the sum of the first 11 terms of the arithmetic sequence 9, 14, 19, and 24. Find the sum of the first 13 terms of the sequence -3, -1, 1, and 3. Given n is 13, first term is -3, difference is 2, and n and e sub n is unknown. Since the last term is not given, so this formula is sub n is equal to n over 2 bracket 2 as the quantity of n minus 1 common difference, that is equal to n over 2 times -3, and is 13. Common difference is 2. That is equal to n is 13 -6 plus 13 minus 1 is 12 times 2. Times is equal to 24. And 13 over 2, -6 plus 25 is equal to 18. Divide, so this is 9. So we have 13 times 9, that is equal to 117. Find the sum of the first 15 terms of the arithmetic sequence 10, 15, 20, and 25. Given n is equal to 15. The first term is equal to 10. Common difference is equal to 5. Then find e sub n. So since the last term is not given, e sub n is equal to n over 2. Yeah, 2. That is equal to 15 over 2 10 plus n is 15. This one, and common difference is 5. So it is equal to 15 over 2 rest, and it is 14. That is equal to 15 over 2 times 20 plus 14 times 5, that is 70. Is equal to 15 over 2 80 plus 17, that is equal to 90. Okay, divide by 2, that is equal to 45. We have 15 times 45. Therefore, E sub n is equal to 675. Find the sum of the first 11 terms of the ARITHMETIC sequence negative 4, 3, 10, and 17. Be given 10 is equal to 11. First term is equal to negative 4. Common difference is equal to 7. Then E sub n is unknown. Solution: E sub n is equal to n over 2 times plus n minus 1 times common difference. So that is equal to 11 over 2. 2 times first term is negative 4 times 11 minus 1. Difference is 7. That is equal to 11 over 2 times 2 times negative 4 is negative 8. And plus 10 times 7 is equal to 11 over 2. It's negative 8 plus 70. 11 over 2 times 0 is 11 over 2. So we have the negative 8 plus 70, that is equal to 62. 62 divided by 2, that is equal to 31. We have 11 times 31, so that is equal to 3, 1. Find the sum of the first 7 terms of the ARITHMETIC sequence 9, 14, 19, 10, is equal to 9. Common difference is a
2 pieces, 3 is 2, 3 pieces.
So is a over 2. 2 quantity of m minus 1 times that is equal to n is equal to n2. That is 9. 19 minus 1.
Susugod tayo.
That is equal to 19 over. That is 19 over 2. We have 2000 is 18 plus 10 is 18 times 5. 18 over 2. 18 plus, so 18 times 5, that is equal to 90. Then okay, so we have 19 over 2 times, so we have 18 plus 90, that is equal to 108, and divide 108 by 2, that is 54. So 19 times 54, that is equal to 1026. Number 5, find the sum of the integers from 8 and 35. So 35 first given. So a sub 1 is equal to 8. A sub n is 35. Unknown is n, so we're going to find a sub n. To solve for n, use the formula a sub n is equal to a sub 1 plus the quantity of m minus 1 times common difference. So a sub n is 35, then a sub 1 is 8 plus the quantity of m minus 1 times common difference is 1. 35, 8 plus, so 35 is equal to 8 minus 1 is 7 in n. Then apply the subtraction property of equality, so that is, so n is equal to 28. Since we already solved n, we can now solve for a sub n. So a sub n is equal to n over 2 times, open bracket, 2 times the first term plus the quantity of n minus 1 times the common difference, close bracket. Then substitute the value of our n, which is 28. Then the value of our first term, which is 8. You have 28 minus 1, then common difference, which is 1. Okay, simplify. So that is 28 over 2 times, we have 2 times 8 is 16. 28 minus 1 is 7. So we can divide 28 divided by 2, that is 14. 16 plus 27 is 43. Then multiply 14 times 43, that is equal to 602. Number 6, find the sum of all even integers from 10 to 70. Okay, given, so a sub 1 is 10, then the last term, or the a sub n, is 70. So since the given problem is even integers, so the common difference is 2, because after the 10 is 12. So we're going to find the value for n and the value for a sub n. To solve for n, use the formula of a sub n is equal to a sub 1 plus the quantity of n minus 1 times the common difference. So we have the value of a sub n is 70, a sub 1 is 10, then common difference 2. 70 is equal to 10, then distribute 2 times n, that is 2n, then 2 times negative 1, that is negative 2. Then combine or add 10 plus negative 2, or 10 minus 2, that is 8, plus 2n. Then by applying the addition or subtraction property of equality, so we're going to subtract 70 minus 8 is equal to 2n. Then 62 is equal to 2n. To eliminate 2, divide both sides of the equation by 2. So the value of n is equal to 31. So we can now solve the sub n using the value for n, which is 31. Then a sub 1 is 10. Then the common difference is 2. So we have a sub n is equal to 31 over 2 times 2 times that is 20, plus 31 minus 1 is 30 times 2. So equals 31 over 2. So we have 20 plus 30 times 2 is 60, equals 31 over 2. So 20 plus 60 is equal to 80. And then divide, so this is equal to 40. So we have 31 times 40. So the E sub n is equal to 1240. Number 7, find the sum of all odd integers from 1 to 50. Given E sub 1 is equal to 1. Then E sub n is 49. Since the given problem is we're going to find the odd integers, so the common difference is 2. So that's coming from 3 minus 1. So n is unknown and E sub n is unknown. So first is solve the value of n. Okay, use the formula. A sub n is equal to a sub 1 plus the quantity of n minus 1 times common difference. Then substitute the value of our a sub n, which is 49. Then a sub 1 is 1. We have n minus 1. Then common difference is 2. We have 49 is equal to 1. Then distribute 2 times n, this 2n. Then 2 times negative 1, that is equal to negative 2. 49 is equal to 1 minus 2, that is negative 1. Then combine 49 and negative 1. So by applying the addition property of equality, okay, 49 plus 1 is 50 is equal to 2n. So in order to eliminate 2, so that the remaining term is only n, so we're going to divide both sides of the equation by 2. Therefore, n is equal to 25. Since we already solved n, we can now solve for E sub n. So E sub n is equal to n over 2 times open bracket 2 times the first term plus the quantity of n minus 1 times common difference close bracket. So substitute the value for n, which is 25. Then the first term, which is 1. So n is 25 minus 1. Then common difference is 2. So that's equal to 25 over 2. Then simplify the number inside the parentheses. So 25 over 2, that is equal to 2 plus 24 times 2. So that is equal to 48. Then add 2 plus 48. $25 times 50. So that is equal to 25. So we have 25 times 25. So A sub n is equal to 625. Number 8, find the sum of the integers from 20 to 130 and are divisible by 5. Given. Given. So A sub 1 is equal to 20. A sub n is equal to 130. Then common difference is 5. To solve for n, use the formula of A sub n is equal to A sub 1 plus the quantity of m minus 1 times common difference. So A sub n is equal to 130, then A sub 1 is 20 plus common difference is 5. Okay, 130 is equal to 20. Then distribute 5 times n is 5n, 5 times negative 1, that is negative 5. 20 minus 5 is 15. Okay, so we have 130 minus 15, that is equal to 5n. Then subtract, so this one 15 is equal to 5n, and divide both sides of the equation by 5. So n is equal to 23. Now, since we already solved n, we can now solve for A sub n. So A sub n is equal to n over 2 times 2 times the first term plus the quantity of m minus 1 times common difference. So n is 23. 2 times the value of our first term, we have 20. So 23 minus 1, common difference 5. Over 2 and 40, then multiply 22 times 5, 23 over 2, 40 plus 110, so that is equal to 150. Then divide 150 divided by 2. So we have 75. So A sub n is equal to 1725. Number 9. If the sum of the first 8 terms of an arithmetic sequence is 172 and its common difference is 3, so what is the first term? Okay, given A sub n is equal to 172, n is 8, common difference is 3, then A sub 1 is unknown. So by using this formula, A sub n equals n over 2 times open bracket 2 times the first term plus the quantity of m minus 1 times common difference. Then so substitute the value of A sub n, which is 172. Then n is 8, then 2 times A sub 1 plus, so So n is 8 minus 1, then difference is 3. Okay, so we have 172 is equal to, okay, we can divide 8 divided by 2, this is 4. Then 2 times the first term plus, so 8 minus 1 is 7 times 3. So that is 172 is equal to 4 times 2 times the first term, then 7 times 3 is equal to 21. Then the next step is to distribute 4. So 4 times 2 8 is 8. Then 4 times 21, so that is equal to 84. So 172 minus 84 is equal to 8a. Then 172 minus 4 is equal to 88. Then 8a a sub 1, so divide by 8, so a sub 1 is 11, so, or this is the first term. Number 10, if the sum of the first 9 terms of an arithmetic sequence is 216 and its first term is 4, what is the common difference? Okay, given b sub n is 216, n is 9, a sub 1 is 4, then we're going to find common difference. Okay, so substitute the value. So we have a sub n is 2016, n is 9, a sub 1 is 4, then times d. Okay, 2016 is equal to 9 over 2, then that is 8, 2 times 4, then n minus 1, that is 8, times d is 8d. And we can apply the cross multiplication. So 216 times 2, that is 432, is equal to 9 times the quantity of 8 plus 8t, 432. Then distribute 9 times 8, that is 72. 9 times 8d, that is 72d. Then apply the addition or subtraction property of equality. 432 minus 72 is equal to 72d, and that is 360 is equal to 72d. Divide both sides of the equation by 72. Therefore, the value for d is 5.